Here we are covering how to graph a parabola. Graphing quadratics is pretty easy. Just plot some relevant points, draw a nice pretty picture through them. We're going to need the y-intercept. We know how to find y-intercepts. We plug in x equals 0. We're going to need the x-intercepts. We know how to find those. We plug in y equals 0. We're going to need the vertex. We know how to find that. Remember, the leading coefficient tells us whether the graph points up or down. Okay, y-intercept, really easy. We know how to do that. We always plug in x equals 0. So if our function is already in standard form, remember standard form, f of x is ax squared plus bx plus c, then finding the y-intercept is the easiest thing ever. If we plug in 0, we get a times 0 squared plus b times 0 plus c. We just get c. Everything else is 0. So the y-intercept, there's no work. It's always 0, comma, c. Whatever that constant at the end is, if we're in standard form. Okay, so y-intercept, done. We got every y-intercept. X-intercepts. Hey, we know how to find x-intercepts. We always, in every situation, plug in y equals 0. Well, remember, f of x is just a fancy way of saying y. So, we want to solve the quadratic equation ax squared plus bx plus c equals 0. The function equals 0. And I say usually here because we won't always be in standard form. We call this standard form of the equation, ax squared plus bx plus c equals 0. Sometimes we'll have our function in vertex form, and then we got to do a little more work. But if we're in standard form, we know how to solve those quadratics. In fact, we know 4 methods for solving quadratic equations. We got factoring, the square root property, which we can only use in special circumstances. We can't use it if we have a b. If we have 3 times x, it won't work. Completing the square always works. Quadratic formula always works. We can solve every one of these. We can always find our x-intercepts. Then we have to find the vertex. We know how to do that. The vertex is the point h comma k. If our function's in standard form, f of x is ax squared plus bx plus c, then h, the x-coordinate of the vertex, is opposite of b over twice a. That's an x-coordinate. To find the corresponding y-coordinate, we plug that back into the function and find k, our y-coordinate. That's if we're in standard form. If we're in vertex form, we don't have to do any work. The vertex will be right in front of us. That's why we call it vertex form. It has the vertex right in front of us. You should watch the video about vertex of a parabola if you're not familiar with this. That's vertex form. Okay, an example. We've got this guy here. F of x is x squared minus 6x plus 8. We're going to graph it by finding all of those relevant features. The y-intercept, we're in standard form. Just plug in 0. It's right in front of us. We plug in a 0, we just get 8. So the y-intercept is the point 0, 8. We'll go ahead and plot it. Draw it on a xy chart. X-intercepts. To find x-intercepts, we always set the function equal to 0. So set the whole thing equal to 0. Now we're solving a quadratic equation. So we plugged in 0 to get the y-intercept. We set the function equal to 0 to get the x-intercepts. Okay, so we just have to solve this. We could use quadratic formula. We could do completing the square. We could not use the square root property on this particular problem because it's impossible to write this left side as junk squared. If we wanted to complete the square, then we'd be able to use the square root property. Or we could just factor. This particular one factors. So that factors x minus 4, x minus 2. Check those details. make sure you believe that, equals 0. So I have two things multiplied together to be 0. That means one of them has to be 0. So either x minus 4 equals 0 or x minus 2 equals 0. We get x equals 2 and x equals 4. So we get two x-intercepts, 4, 0, 2, 0. X-intercepts are points. We got those by plugging in y equals 0. So in an x-intercept, you always have y equals 0. It's where you're hitting the x-axis, y equals 0. Okay, we got a couple of x-intercepts now. Let's throw those on our graph. A here is positive. We know the graph's going to point up. We're almost done. We could just kind of roughly sketch our parabola in here. You could see it would look like this. Ooh, right through here, it's going to point up. The vertex is going to be right here, halfway between these x-intercepts. I can see right off the bat, the vertex is going to be here at 3. I just don't know how low it's going to go yet. So let's find the vertex. Vertex is a point, h, k. H is opposite of b over twice a. B here is -6. Opposite of -6 is +6. A is 1. Twice 1 is 2. 6 over 2 is 3. We're halfway done. The x-coordinate of the vertex is 3. Hey, we saw that just looking at the picture a second ago. To find the y-coordinate, you always take that h you just found and plug it back into the function. So we evaluate f of 3. Check these details on your own. But plugging 3 back in, we get -1. So our vertex is the point 3, -1. We can throw that here on our xy graph. We could see exactly what the parabola is going to look like. Notice that vertex is the minimum point. Whenever a is positive, the vertex will be a minimum. We draw a nice pretty curve through them. Here's our quadratic. Okay, another example. This one's a little different because we're in vertex form instead of standard form. Okay, so the vertex is right in front of us. Remember, vertex form is a x minus h squared plus k. So the vertex is the point h, k. H is the opposite of what we see inside. You just have to get used to that. We're thinking x minus h, so this would be x minus -5. Or another way to think of it, h is the opposite of what you see right here. H is -5. K is whatever you see outside. If you see plus, it's plus. You see minus, it's minus. So our vertex is the point -5, 12. We see right here, we have a negative a. So this graph is going to point down. This vertex will be the maximum point, and we're going to point down from there. To find the y-intercept, we always plug in x equals 0. Okay, it's not right in front of us here. We're not going to get 12. We're not in standard form. We do have to actually do a little work here. So just plug in x equals 0. Check these details on your own, but we get -63. So the y-intercept is a point, not a number. 0, -63. To find x-intercepts, we always plug in y equals 0. Where's y? The function is y. This side is y. We make this side 0. We set the function equal to 0. Here, because we don't have that linear term, because it's possible to get this parenthesis squared by itself, we'll be able to use the square root property. Move that 12 to the other side. Divide through by this -3. Hey, look, we've got junk squared equals a number. We can use the square root property, take the square root of both sides. Whenever you take the square root of both sides, you must put a plus or minus on this right side. On the left, square root of stuff squared is just stuff. We get x plus 5. On the right, square root of 4 is 2. So we have x plus 5 is plus or minus 2. Move the 5 over. X then is negative 5 plus or minus 2. Negative 5 plus 2 is negative 3. Negative 5 minus 2 is negative 7. So my x-intercepts are the points negative 3, 0, negative 7, 0. Intercepts are points, not numbers. Okay, so we have our y-intercept that we found, these two x-intercepts, and the vertex. We know the graph points down because A is negative. We draw a nice pretty curve through them. Okay, one more example. We want to graph this quadratic. Y-intercept, or in standard form, y-intercept's right in front of us. Just plug in x equals 0. You can see you get 5. Y-intercept is the point 0, 5. For the x-intercepts, we would set the function equal to 0. This is not going to factor. Quadratic formula is your friend here. Check these details on your own. Actually work this out. But the quadratic formula gives you complex x's, complex solutions. We can't graph those. Complex solutions do not correspond to x-intercepts. So this graph doesn't have x-intercepts. Sometimes we don't end up with any x-intercepts. Sometimes we get 1, sometimes we get 2. Whenever quadratic formula spits out complex solutions, you don't have any x-intercepts. The vertex, check these details on your own. Go through the math. For the vertex, this is what we get. If we plot all of those, this is what the graph will look like. So here's our vertex. Here's our y-intercept. Our graph sits completely above the x-axis. No x-intercepts. Okay, that's graphing quadratics. It's really easy. Find your vertex, find your x and y-intercepts, draw a nice pretty picture. Okay, click on any of these other videos now popping up about vertex or graphing quadratics.